Greetings everyone, I am Nicholas Kurt, and today I'll be doing some practice problems for you on acids and bases regarding calculations for pH and pOH to help you hopefully understand more about them. Right after this intro. Here's our first question. What is the pOH of sodium hydroxide, NaOH, if the concentration of the base is A, 0.3 times 10 to the power of negative 2, B, 0.133 moles, and C, 1.6 times 10 to the power of negative 3 moles? And lastly, what is the pH? So for A, we are given the concentration, which is 0.3 times 10 to the power of negative 2. We are required to get the pOH of the solution. The equation for pOH is that pOH is equal to the negative log of OH minus. So our pOH is equal to the negative log of 0.3 times 10 to the power of negative 2. So our pOH is that if we take this, we'll input it into our calculator and we'll get our answer. Our pOH is equal to 2.5. For question B, we're once again given the concentration, which is 0.133 moles, and we are required once again to get the pOH of the solution. pOH is equal to the negative log of the hydroxide concentration, and so our solution is that the pOH is the negative log of 0.133 moles. We'll take this, enter it into our calculator, and we get that our pOH is 0.876. For C, we are given the concentration once again, which is 1.6 times 10 to the power of negative 3. We are still required to get the pOH of the solution, so the equation stays the same. pOH is the negative log of the hydroxide concentration. So the solution is that the pOH is equal to the negative log of 1.6 times 10 to the power of negative 3. So we'll take this, enter it into our calculator, and we get that the pOH is equal to 2.8. Now for question D, we are required to get the pH of questions A, B, and C. And we are given the pOH, which is 2.5, 0.876, and 2.8. To get the pH from pOH, we'll simply subtract 14 from the pOH. This gives us the solution that the pH is equal to 14.0 minus 2.5, 14.0 minus 0.876, and 14.0 minus 2.8. This gives us the answers that the pH is equal to 11.5, 13.1, and 11.2. Here's our next question. What is the pH of a solution of sulfuric acid, H2SO4, if the concentration of the acid is A, 0.050 moles, B, 2.5 times 10 to the power of negative 4 moles, and C, 1.5 times 10 to the power of negative 4 moles? We are given the concentration of the acid, which is 0.050 moles, and we are required to get the pH of the solution. To get the pH, it's very similar to the pOH. The pH is equal to the negative log of the hydrogen concentration. So our solution is that the pH is equal to negative log of 0.1 moles, not 0.050. We are given the concentration of the acid, and in the acid there is 2 hydrogen molecules for every mole of acid. And so, we must double our acid concentration to get our hydrogen concentration. So the answer we get is that the pH is equal to 1.0. I went ahead and filled in the given, required, and the equations for B and C since the question is all the same. The given for B is that the concentration is 2.5 times 10 to the power of negative 4 moles. Our required and equation stays the same. Our solution is the negative log of, once again, 5 to the power of 10, not 2.5, because as I mentioned earlier, we must double the acid concentration to get the hydrogen concentration. So 5 times 10 to the power of negative 4, we enter this into our calculator, and we get that the pH is equal to 3.3. For C, we are given the concentration of the acid once again, but the concentration this time is 1.5 times 10 to the power of negative 4. Our equation and our required are still the same. The solution, negative log of 3 times 10 to the power of negative 4. We will take this value, we enter it into our calculator, and we will get our pH. And our pH is 3.5. Bonus question, find the hydroxide and hydrogen concentrations in a solution with a pH of 4 and with an OH concentration of 1.2 times 10 to the power of negative 3. For A, we are given the pH of 4, and we are required to get the hydrogen and hydroxide concentrations. The equation is for H plus is that it is equal to 10 to the power of negative pH, while OH is equal to 10 to the power 1 times 10 to the power of negative 14 divided by the hydrogen concentration. The solution is that the hydrogen concentration is equal to 10 to the power of negative 4, while the hydroxide concentration is equal to 1 times 10 to the power of negative 14 divided by the hydrogen concentration of 10 to the power of negative 4. Our answer is that H plus concentration is 1 times 10 to the power of negative 4. The OH concentration is 1 times 10 to the power of negative 10. For B, we are given the OH concentration, which is 1.2 times 10 to the power of negative 3. We are required to get the hydrogen and hydroxide concentrations. The equation to get the hydrogen concentration from the hydroxide concentration is 1 times 10 to the power of negative 14 divided by the hydroxide concentration. H plus is equal to 1 times 10 to the power of negative 14 divided by 1.2 times 10 to the power of negative 3. Our answer is that H plus is equal to 8 times 10 to the power of negative 2. OH minus is equal to 1.2 times 10 to the power of negative 3. That is all, and I hope you learned something new.